Hello and welcome back to GLB Productions. Bruno Luce here. Thanks for joining me. In this video, we'll be taking a look at the Yamaha MG12XU mixer, which is the small brother to the MG20XU recently covered on the channel. This is a 12-channel mixer with many similarities, but also some important differences to the larger model. As always, we'll start with an overview of the entire mixer and then look at each part in detail. The audio you're hearing is a 50-50 blend of my lavalier mic and the output from the console, unless otherwise indicated. So, to begin with, you can see that the mixer is divided into a channel section and a master section, also referred to as the input and output sections. There are a total of 12 inputs, 4 mono input channels, 2 stereo mono hybrid channels, and 2 stereo channels. This includes 1 channel input which is switchable between analog and USB inputs. The output section has main stereo outputs on both XLR and quarter-inch connectors, 2 aux sends, 2 group outputs, a monitor output, and a headphone output, all on quarter-inch connectors. The back panel of the mixer has an IEC socket for the internal power supply and a B-type USB connector for the USB input. Now, let's move on to the channel section. The first 4 channels on this mixer are mono and feature an XLR combo connector. This accepts XLR connectors as well as in the center balanced or unbalanced quarter-inch connectors. The XLR input will generally be used for microphones, the center quarter-inch connector for instrument or line level sources such as keyboards, active acoustic guitars, and active basses. Input impedance is only 3 kiloohms, so this is not suitable for direct connection of passive sources, as some high-frequency loss will result due to pickup loading. There is also no high Z mode on these inputs, so passive sources should be connected using a DI box. For more information on this, please see my video series on DI boxes, link in card. Below the input, you will see a pad switch that drops the input level by 26 decibels. This is useful for very loud input signals, for example kick drum or snare drum, or very powerful singers. Next to that is a high-pass filter, HPF, set at 80 Hz with a filter slope of 12 decibels per octave. This is used to remove unwanted low-frequency information from the input signal, such as air conditioning noise, rumble from large trucks passing by, etc. This should be switched in for all non-bass signals and should be switched out for signals such as kick drum and bass guitar. We'll just demonstrate that on the first channel. Check, check, 1, 2, 3, 4. This is the high-pass filter in. Check, check, 1, 2. And this is the high-pass filter out. Check, check, 1, 2, 1, 2. Note that the pad and HPF apply to both the XLR as well as the quarter-inch sections of the combo connector. These are combined internally. We then have the gain knob, the function of which is to bring the input signal up to the point where the mixer can deal with this. A quick recap on this. The output levels of most microphones, known as mic level, is between -40 and -60 dBV. That's between 0.001 and 0.01 volts. Most mixers operate at line level, which is around 1 volt. This can be referred to as 0 dBV, which is exactly 1 volt, or more commonly as +4 dBu, which is 1.2 volts. Both are used depending on which reference voltage is chosen. There is also consumer line level, which is -10 dBV or 0.3 volts, which explains why some gain may still be necessary when connecting CD players, iPads, and the like. In a similar way, almost all electronic instruments operate somewhere between mic level and line level, although the input of some electronic keyboards can be very high indeed, necessitating the use of the pad switch. Okay, so now that's cleared up, let's look at gain setting procedure. My recommendation on this mixer is to start with the compressor knob fully counterclockwise, channel fader all the way down, channel switched off, and the master fader at 0 dB. Press the PFL button on the relevant channel down here. Speak or sing into the mic or play the instrument as appropriate, and raise the gain knob until the meters indicate a level of around 0 dB. Check, check, 1, 2. Check, 1, 2. Check, check, 1, 2, 3, 4. Once that's done, you can release PFL, turn the channel on, and raise the channel fader. Check, check, 1, 2. Check, 1, 2. There's no need to hit 0 dB exactly all the time. It's just intended as a guide. Remember, there are no correct settings for this gain knob. It'll be different for each input, as everyone speaks, sings, or plays their instrument differently. An exception to this would be the left and right sides of the same stereo signal. For example, if gain is around 11 o'clock for keyboard's left, it's reasonable to assume that the gain on the right side of that same keyboard would be around 11 o'clock as well. If you find that the signal is at or above 0 dB on the meters, even with the gain all the way down, then it's time to engage the pad switch, which will give you the necessary gain range to deal with louder sources. The white on black numbers here show the normal gain range. The black on white numbers show the gain range with the pad switch engaged. While we're here, let's cover the phantom power switch, which supplies 48 volts DC to pins 2 and 3 on the XLR inputs only. This is used for powering condenser microphones as well as active DI boxes. Dynamic mics such as the SM58 ignore phantom power and can be used safely with it on. Just remember not to plug and unplug mics while this switch is on, or you'll get very loud bangs and thumps going through your PA system. Next, we come to the compressor knob. I've done a full video on the concept of compression and how this function works on the previous generation of MG mixers, so please take a look at that for more information, link in card. The stats on this compressor have changed slightly from the older version, as you can see on the screen, but in practice its use is very similar. Personally, I'd start with the compressor off, fully counterclockwise. If you feel that the signal has too much dynamic range, in other words, you're constantly riding the fader up and down, try setting the compressor to 12 o'clock and adjust from there. It's a process of experimentation, and there's no correct setting for any input. The correct setting is the one that keeps the dynamic range under control and sounds the best to you. Bear in mind, however, that this type of compressor adds gain as you turn the knob clockwise, so it may cause feedback in a live sound situation. If that happens, you can wind your gain back just slightly. We then come to the equalization or EQ section. On this mixer, we have a 3-band EQ with fixed frequencies, a shelving low at 100 Hz, a shelving high at 10 kHz, and a peaking mid at 2.5 kHz. For a complete discussion of this EQ, as well as suggestions on how to set it, please see part 1 of the recent MG20XU series, link in card. Now we'll have a demonstration of the EQ section. Channel is on. Check 1, 2. This is flat. The highs, check, check 1, 2. Check 1, 2. Check 1, 2. Check, check 1, 2, 3, 4. The lows, check 1, 2. Check, check 1, 2, 3, 4. Mic check 1, 2. Check, check 1, 2, 3, 4. And now the mid-range. Check 1, 2. Check 1, 2. Mic check 1, 2. Check, check 1, 2. As I say in many of my tutorials, begin with the EQ set flat. If it sounds good, don't adjust it. After this, we come to the auxiliary section. The MG12XU has two aux sends. Aux 1 can be set pre or post fader and is generally used for stage monitoring in a live sound situation set to pre-fader. For a full explanation of what pre-post fader means and when to use each one, please see part 2 of the recent MG20XU series, link in card. Aux 2 is fixed post fader and feeds both the mixer's internal effects engine as well as the aux 2 output located in the master section. Note that both can be used at the same time. Plugging into aux 2 output does not disable the internal effects. However, having only one control for two separate purposes would probably be somewhat inconvenient. To use the internal effects section, select an effect using the program knob, turn and then push down to confirm. In this case, we'll use number 1. Get your channel working as normal. Raise the white aux 2 knob on the respective channel and then raise the FX return fader to route the affected signal back into the mixer. Obviously, you would turn it on. Check, check 1, 2. Check, check 1, 2. And there's your effect. In a live sound situation, you would use the FX return and channel faders to blend between the dry or unaffected and the wet or affected signal. You can also turn the FX on and off using this or by using a foot switch plugged in to the foot switch socket in the connector section next to the headphone output. The blue aux 1 knob above the FX return fader is used to send the wet or affected signal to stage monitors that are connected to the aux 1 output. For a full explanation of the concept behind internal effects, as well as a rundown of all the effects and their variations, please see part 3 of the MG20XU video series, link in card. Below the aux section, you have a pan knob, which pans mono outputs between the left and right mixer outputs. As you can hear in this demonstration, channel is on, panning left, check, check 1, 2, check 1, 2, pan center, and panned right, check, check 1, 2, 1, 2. This knob is also used in conjunction with the group 1, 2 buttons and fader, which we'll demonstrate when we cover the master section. Below the pan knob is a channel on button. When this is off, it's the equivalent of pressing mute on other mixers. It's important to note that on this mixer, both aux sends are post-mute. So when the channel is off, everything is off, including stage monitors that are connected to aux 1 and external effects units that are connected to aux 2. This is my preferred configuration for live sound because it allows you to kill feedback on stage with a quick button press. Below this, you have a red peak light, which illuminates when the input signal is 3 dB before clipping, and thus serves as a warning that your input signal is about to become distorted. This is particularly important when recording. This light can come on occasionally, but it should never stay on. If it does, you need to reduce your gain. A quick demonstration of this. Channel PFL is on. I'm going to turn the gain up until the peak light comes on. Check, check, 1, 2, 2, 2, 2. There you go. Finally, we come to the fader as well as the channel routing buttons. Let's begin with the fader. This should generally be positioned somewhere around 0 dB, as this gives you the most resolution when mixing. As you can see at this position, there is quite a bit of travel between 0 and 10 dB. When you're down here, a relatively small amount of travel gives you 10 dB of change. If your faders are way up at the top of their travel, it's generally an indication that you need to raise your gain settings. On the other hand, if they're way down at the bottom, it's often a symptom of a power amplifier or active speaker level that is set too high. Remember also that these faders work in conjunction with the master fader, which should generally be set around 0 dB and not change very much. At this point, let's discuss the channel routing buttons. The gray 1-2 button and the red ST button. These tell the mixer where to send the channel signal once it has passed through the fader and work in conjunction with the pan balance knob here. The simplest way to route a signal is directly to the main stereo outputs. In order to do this, ensure that the red ST button is down and the gray 1-2 button is not. This will route any channel that is on directly to the main outputs via the master fader, bypassing this group fader entirely. This is fine for most users, and in fact many professionals mix like this. You do not have to use the group function if you don't need it. Having said that, when would we use the group function and routing buttons? The first time would be when we have a group of similar inputs. For example, let's say that you have 4 backing singers on channels 1 to 4. All of them have slightly different EQ, gain, and pan settings, and slightly different fader positions once you have balanced them to their respective voices. So what happens during the show when you need to turn all of them up or all of them down? You can try and move 4 faders at the same time, but chances are is that you will disturb their relative positions. This is where the subgroup comes in. What you would do is you would engage the 1-2 routing button on each channel and disengage the red ST button. Then on group 1-2 fader, engage the red ST button and raise the fader to unity. The group 1-2 fader thus allows you to control the level of all 4 of these channels simultaneously. So using our example of 4 backing singers louder, backing singers softer. This application is commonly used for similar instruments, for example, drums, stereo keyboards, or a guitarist who has maybe multiple guitars. You can also use the group outputs separately from the main left-right outputs. For example, to feed delay speakers, front fills, a recorder, etc. In this case, you would engage both ST and 1-2 routing buttons and disengage the ST button on the group fader, because you are using the group output to feed a separate set of speakers. If this is used for recording, you would press down the 1-2 button on the channels that you want sent to the recorder. It's important that in this application, we disengage the red ST button on the group fader in order to prevent duplication of the signals from each channel being sent to the main stereo outputs. Finally, it's important to note that when the 1-2 routing button is engaged, the pan knob does double duty, sending the signal to group 1 when panned hard left and group 2 when panned hard right. It's thus possible to create multiple mixes using this function, in particular in recording environments. The topic of subgroups is quite an extensive one, more than the time we have to cover in this video, but I hope that this has given you the basics.